Okay, here we go. We're on lesson 76. Open your books to lesson 76 so that you can see the pictures in the books. Ben, where's your book? Thank you. Susie, where's your book? Allie, where's your book? Everybody, lesson 76. Because I want you to see the pictures in the book. They can draw the pictures much better than I can draw the pictures. Okay, when you're looking at this first picture here, what would you say about that picture? What?
Looks like a neighborhood.
It looks like a neighborhood. Okay, anybody else with maybe less out there description of, can anybody see? Mark.
It's symmetric on both sides.
It's symmetric. Which axis would you say it's symmetric about? Okay, which would be the line where you would fold it and it would meet?
Y.
The y-axis, right? It's symmetric about the y-axis. You could fold it on the y-axis and it would meet. Duncan, do you want another slash on the board? Thank you. Okay, so it would meet when you fold it. Let's see my books a little bit. There's the function. You see? There you go. Okay, so it is symmetric about the y-axis. Now, look down here at this graph at the bottom of the page. What kind of observation could you make about that graph? Okay, if you did on this one, if you looked at it, it would be symmetric. How? If I looked at here on the right, I go high. On the left, I go the same distance low.
Reflection.
Okay, and then over here, I go down. Isn't this like if you were going to turn this one and swing it around here, it would be this one, okay? But it's not a symmetry. It's like this one is, like Mark said, reflected down underneath there, okay? Now, this is what we're talking about today. Even and odd functions. Okay, and an even function, Wesley, did you lose my place?
No, your book lost its own place.
Okay, shh. Even functions. The cosine function is an even function. Okay, and even functions have that property of being symmetric. Thank you, Wesley. I appreciate that. Okay, of being symmetric about the y. Symmetric about the y-axis. Okay? The sine function is odd. Okay? It is odd. And it is not symmetric. What is the sine function like? Remember, the cosine function looks like this. It starts high, it goes low, it comes back up, but it's doing the same thing on each side. That's the cosine function. What is the sine function?
Sine function crosses at the 0, 0.
Okay, over here it's going high, then it's coming low, and then it's coming up again. Over here it's doing the opposite, isn't it? It's going down, and then it's coming up, and then it's going down. All right, so the sine is odd, like the bottom one on the page. The cosine is even, like the top one on the page. And we're talking about what are the properties of these two functions? Now that you can visually look at them, what are the properties, okay? Now, look at the bold print. Bold print is always nice, okay? It says the graphs of even functions are symmetric about the y-axis. So we already said that. That's an even function, okay? Now, if the distance from the x-axis to the graph is the same, but in the opposite direction, then we say it is an odd function. So what they're saying, the distance from the axis is the same, but the function is going in the opposite direction. That is an odd function, okay? So now we're going to talk about the equation properties of these two. Okay, well, they're going to do it somewhere. Oh, there it is. The odd function for the even function, f of negative x, is the same thing as f of x. Okay, and they're saying that up in the first paragraph there, right there on the first paragraph, they're saying that, okay, that whenever you could plug in a negative x into the function and get the same thing. It's an even function, okay? Now, but f of negative x on an odd function is going to be negative the function at x, all right? So basically, if I'm over here and I say f of negative 45 degrees, okay, is not going to be the same thing as f of positive 45 degrees. They're going to be the same thing but opposite signs. And that is the odd function. Okay, so everybody turn the page. We are on 466. Okay, and they're showing you why the sign is odd. Because if I take sine of negative 30, where is negative 30 on my right? It's down here, right? There's my negative 30, right? And my sine of negative 30 is what?
One half.
It's close. It's not 1/2, it's
Negative 1/2.
negative 1/2. It's going to be negative 1/2, right? The sine of positive 30 will be 1/2. Okay, so when you look at the sign, does it follow this rule? The sine of negative 30 is opposite the sine of positive 30. And it works all the way around the sign. Okay, if I take the sine of negative 90, and it should be equal to negative the sine of 90. All right, so we look and we see sine of negative 90 is down here. It's a negative 1. The sine of positive 90 is up here. It's positive 1. And they're opposites of each other. And that's what an odd function does. Okay? Now, what about this function, the even function? Can you think of one of our parent functions that would be an even function? What's that mean? No, I'm talking about this. Like y is x squared. Okay? Y is x squared. Y is x squared is a parabola. Remember, that's our parent parabola, right? And it's facing up. Okay? It's a parent parabola facing up at 0, 0. Why is that an even function, Ian? Why is that an even function?
It's facing up.
Allie.
It's the same on both sides.
It's the same on both sides. Very good. That if I have the function, if I plug in a negative 1, I get a 1. If I plug in a positive 1, I get a 1. If I plug in a negative 4, I get a 16. If I plug in a positive 4, I get a 16. It is symmetric. And this is true. That when I plug in a negative or plug in a positive, I'm going to get the same thing out. All right? So when you think of even functions, I want you to think of the cosine, Wesley, / I want you to think of the cosine, and I want you to think of a parabola at 0, 0. Those are even functions, okay? When we have another classic odd function besides the sine, what function is that?
It's cubic.
Y is x cubed. That is my parent cubic function. Okay? Is this function an odd function? If I plugged in negative 1, I'm going to get out a negative 1. If I plug in a positive 1, I'm going to get out a positive 1. Are they opposites of each other? The same value, but opposite signs, right? If I plug in a 2, I get out a 8. If I plug in a negative 2, I get out a negative 8. Okay? So this is what's happening there. The cubic is an odd function. Okay? So, now up here on the top of 466, all they're trying to do, explain to you, get you to see by plugging in points why the sign is odd. Okay? And then down at the bottom, they're showing you the sign function and what it's doing. Where it goes up over here, it's going to go down in the same distance over here. When it goes down over here, it's going to go up the same distance over here. Okay, they're going to be exactly the same, but opposites. All right, so now look over here. And what about the tangent? The tangent of theta. All right, what is the tangent? The tangent, remember, is made up of the sine of theta over the cosine of theta. Where did I come up with that?
Rule of math.
Tangent is what? Opposite over adjacent, right? Tangent is opposite over adjacent. What's the sign? Opposite over hypotenuse. Watch my computer.
Oh,